All right. Welcome to the first live demo of Nono connected with SPIFFE Spire today. We are going to be talking about how we are working on the open source runtime layer that will give your agent amnesia about credentials at exactly the right moment. I'm going to give us a couple of minutes as people begin to trickle in. And if you are on the call at this time, go ahead and jump into the chat. Let us know if you are currently using Nono, if you are wanting to use Nono, and if there's any particular questions that you have along the way as we explain to you what we have been developing. Please throw those into the chat. We might answer them with our live demo. We can definitely answer them in the Q&A that follows. You should expect this to take around 40 minutes in total with the Q&A, so we will be respectful of your time, but give us those good and interesting questions. I myself am Sal Kimmich. I am a security architect with Nolabs, and our live demo today is going to be provided to you by Aleksy. This is going to be very, very interesting. I see that we've got a good number of people that are joining into the call. We're 2 minutes in. Let's go ahead and get started. So glad you all could make it. So before we get technical, let's just think about the sort of highest level order we can think about this problem. The nice metaphor that I like to think about with this is that when we're working with agents, we have a problem that we're giving them authority that is far beyond what we'd be giving a typical developer. It feels a lot similar to the problem of asking to have a hotel guest have the master key when all that you want that hotel guest to have is only access to what it should have access to, and importantly, not have access after it leaves. This is exactly the approach that we're taking with Nono, and it's why the structural isolation that we're taking is a paradigm shift, I believe, for the way that we should think about sandboxing. So this is the problem that we're seeing. Typically, an agent is going to hold a key for the entire session. Now, this is a problem that we need to get around because it's been a known problem for a long time. This creates something that is exactly the same as what Hardy named in 1988, the confused deputy problem. If we have a program or an agent running with more authority than the request it is acting on, you have a problem. If prompt injection from an LLM creates that problem for you, we've seen in the news exactly what that can do. So let's handle this in a different way. What we want to do with Nono is to change the way that we have been scoping and thinking around sandboxing. Traditional sandboxes will scope a process for its lifetime. Instead, I now need, in an agentic reality, to scope to a single invocation. This means that the file system and network access are granted, used, and revoked around specifically the tool call, not the session that contains it. And that allows us to have some pretty powerful security protections, and it helps us a lot with audits, as you'll see. And before we really start diving into how this works, there's a couple of core principles that I always like to pull on when I'm thinking about security. And it is interesting. If you have a strong security background, you have read and completely consumed the realities of these papers. There are a few papers, including the Anderson 1972, where they defined a kernel and a security kernel. All of the requests around making a easily observable, tamper-proof audit to the lowest layer requests that we have been having for 50 years around computers, I think are really well adjusted for in Nono. So the shift that we really need to make here is understanding that the agent is going to break the shared assumption that we have, that one process performs many different scopes and actions chosen at runtime from untrusted text. We don't want that. We have to change the unit of enforcement. Now, underneath nono, we are using Landlock and seatbelt. This is something that is non-proprietary, available to you to use, but nono is using it in a different way. So you will note that Codex does use this, but they are still using an old paradigm of having that process scoped policy. We'll just show you in the demo just how much this changes if you now do it just by per invocation. Because what this is going to allow you to do is no longer have to work with a blanket policy. You're going to create a specific nono profile that is templated and is specific to the permissions that you are allowing for Git or GitHub or curl or kubectl, and many more that I've provided a few templates for you to play with later. Because think about this in your own work. If you are using agents, either at home or in enterprise, I might assume that you're using Git, GitHub, and curl. You should have specifically scoped permissions for those. And if you're interested in that, this is a very easy way to contribute and get started with nono today. Because when you instantiate nono, it takes less than a minute to set up. Then you should do a bit of thinking around the policies of what you do and do not want to exist or be available. That's interesting, and I can provide you with a core set of standard, Git and GitHub suggestions for templates, but this is as personal as it is to your own personal risk profile and the regulation that your production environment sits within. And you can scope it to those. So the claim that I've made to you today, and the reason why we have all joined here, is that we want to ensure that we have architected this in a way that a secret in that the need to create and instantiate the agent will never be seen by the agent itself. So the agent can send a request, no header. This is going to go to a nono proxy, which is going to inject the real credential outbound. And then we're going to provide a phantom token that looks similar to what it is expecting to receive, but that allows us to completely ensure that the credentials are never held where the agent can see them. And if you are working on sort of the moving and bleeding edge of this, then you're probably familiar with the AWS SIG v4, even when there's no header to inject. Nono makes this incredibly useful. So Nono's broker holds the signing material itself, and then it constructs the signature per invocation. So this works great for headless as well. So for those of you that have been living in SPIFFE and SPIRE and think a lot about secrets and credentials, you have a few ways where you know that the secrets are likely to land. Here's a quick way to think about why the other processes are good, but the argument that I'm making at the bottom here, which my head might cover, is that when we use the nono phantom token, the credential is going to be inside the proxy only and never forwarded. So we, for the first time, have a structural isolation. That is what I mean by that, and that is how this compares to all of the other implementations that you might be architecting around this right now. A quick note, I think this is worth thinking about if you are thinking seriously in this field, is what happens if the supervisor is compromised. So it's a fair question, but the answer will depend on where the attack starts. So if it's from the child, you will be protected. If it's from outside, you will be isolated. If there's a compromise that sits inside of the happy paths that you construct for nono, We cannot do magic. We can only prevent and allow. But that is not news. That is simply how computers work. So if you want to be serious about making sure that your policies for read, write, get, all of these systems are exactly as they need to be in terms of the policy that your company or organization has, we can get that and we can verify it now at the L7 layer. That is what we have here, and that's why the auditing that Nono lets us do is so interesting and powerful. But I assume here that you might be a little interested in identity if you are watching this demo. So brokering is going to solve possession for us, but it doesn't solve existence. There's really an identity problem that we want to tie this to for this to be useful to a lot of people's current infrastructure. But thankfully, the two superpowers that SPIFFE, Spire, and Nono put together give you, this is, I think, incredible. So SPIFFE and Spire is created as a bunch of templates and mechanisms that allow you to get identity without a secret. So the workload should never prove anything about itself. It's got to be short-lived, continuously rotated. This is the infrastructure that sits in a lot of our banks. It authorizes nothing, it constrains nothing. Now, if you tie that idea to enforcement at the tool call, then we've got something really interesting. I now know who, as in a human being, constructed the policies that the workload was allowed to engage over, and I can see every call that was made during runtime. This is the most lowest grain audit mechanism that I think we have over the kernel right now. So when you put these together, you get identity without enforcement. Originally is going to give you the confused deputy. Every action can be proved attributable, but none of them can be necessarily prevented, right? You don't have the blocking mechanism that Nono gives you. Enforcement without identity is an anonymous log, and it's not terribly useful. But when you put these together, every call is going to be scoped at the kernel, and every credential is going to be brokered rather than held. Every audit record names the attested workload outright. And the agent is going to get an identity, but not a key. So Spire is going to give us our SVID. It's going to be cryptographically verifiable. And then we're going to take this very simple process. And remember, this is all socket driven. So the Spire agent is going to run in the node, and it's going to attest the workload. The supervisor registers the workload. It holds the socket. And then the sandbox child has no workload API and no socket access. This is the fundamental reason why I'm calling this amnesia. It is not possible to recover that. A quick note. So the guarantee is only ever going to be as strong as the selector. Everything that you're seeing in this demo today, my team created in a little less than a week and a half. We are still hardening it. So today what you're going to get is the Unix UID. There's other things that we can do to build this out. We're looking for your ideas. And in this demo, right, this is really what I want you to think about. We saw this in a slide earlier, but it was as simple as I could make it for you. The reason why I was inspired to try to get this work moving is because I think the regulatory requests or the policy suggestions or architectural suggestions that have been made here are strong. I really like the RFC 7523. We're using a couple of what I think are the strongest architectural isolation practices around identity, and then tying them down to layer 7. And just to restate this one more time, do go in and look at these reference implementations. Let me know if there's anything that we could make to make these more powerful or even more closely aligned, because I think uniquely with Nono, we have the granularity to be able to get this right. With that, I am very excited to introduce to you one of the most hardworking engineers I've run into in a while, who has put this entire demo together. And Aleksy is also the person that you should be asking your most difficult technical questions to today. I would love to recommend. So with no further ado, go ahead, introduce yourself, and show us how this actually works.
Cool. Thank you so much, Sal, for the introduction. I see a question real quick in chat, which the demo will cover. How do you transfer the token to a sandbox? So as I said, we'll cover that. We'll showcase how all of it works. And let me just set up my screen real quick. Cool. So yeah, I am Aleksy Siek. I am a founding engineer here at Nolabs. I am a core maintainer of Nono. I've been working on the project for the past 2-3 months maybe, and we've made a ton of progress, and we'll showcase some of that today. Before we get to SPIFFE, I'll be establishing some foundational features that will build up to using Spire for anyone new to Nono and does not have yet great knowledge of maybe what even Nono is. So I'll be going through profile creation, wiring the credential inside the profile. We'll be looking at the audit trail afterwards, and then we'll do some live attack attempts in between. So this is what I just covered. You can take a quick look. Let me swap over to my terminal. So installing Nono, extremely easy. You can do a quick curl. The script will run. You can do a brew install. We have support for Debian, Arch, Nix, pretty much the majority of the largest platforms. And everything I will be speaking about today, you can take a look at the live documentation up on our website. So what is a profile? A profile is a composable block that allows you to establish your capabilities. You could do it through the CLI, but of course, these capabilities build up quick, especially as your different harnesses use different configs, different caches, so on and so forth. So profiles are a really good way to be able to iterate upon any extra capabilities you might require and share it with your team. And known overall, you can think of it in kind of 3 compartments, as Sal has stated before. You have the supervisor, the proxy, and then the sandbox, which is very similar to I like to think of it as a prison complex, with the supervisor being the warden, who has clear oversight over the whole prison. You have the cell guard, the proxy. It can frisk the prisoner when they're leaving the cell, aka network filtering, and then the prisoner being the sandbox. And you have to keep in mind, it's not only an agent wrapper, it's basically a process wrapper. So you can use any tooling inside Nono, not only an agent execution. So yeah, it's one binary, no config files yet, nothing. So I'll quickly cover probably how the majority of our users use Nono as of today. And I'll be using the cloud pack because we have the most downloads on it. So we could go ahead and pull the pack down. And a pack is an extension of a profile. A profile is a single JSON file with all of their capabilities. A pack is a large compartment. It can contain hooks, skills, and the profile, the policy itself. The reason we have some skills included is to make the sandbox itself aware it is running in a sandbox, because otherwise, if you are restricted, if the agent hits a restriction, it cannot access some type of document, some type of file, it won't know what happened, and it might be unhelpful. And the skill allows it to know exactly why it happened and then give you a recommendation. So we couldn't access this SSH key. Do you want to add it to your profile? And so forth. So we have pulled down the Nolabs AI cloud pack from a registry. And the registry is where teams can publish their vetted profiles. And if we do nono profile list, we can take a look at some of the built-in profiles. These are embedded in the binary. We have some of the packages, as I said, the packs. These are the big compartments for different agents. And then we have some of our user authored profiles. And then before I get to the full demo, we have a feature called extension. So within your authored profile, for example, within Claude GH, I extend the Claude pack. So I don't have to write every single permission again within my profile. I can just refer to the Claude pack, and then we will inherit all the capabilities from it inside the Claude GH pack profile. So as I said, the majority of our users will likely pull down the Claude pack, and then they can do something like allow. Let me move this out of my screen. So they can do allow current directory. As I expect the majority of our users go into a project that they're working on, they do not want the agent to access outside the project. Let's do -s for silent, no verbosity, just for the demo. And then we can do Nolabs profile. The -- showcases that this is the command we will be running within the sandbox. So let us instantiate Claude. The first time you will do this, you will have a prompt, a real prompt, not an AI prompt. You'll have to log in to Claude, which I have done already. And then let's try to summarize this project in one sentence. This is a very basic demonstration that it does work. Now let's ask it to take a peek outside of this project. As you can see, it tries to run ls. It fails. And then because we are using the Claude pack, it is aware that it is running in a nono sandbox and has the knowledge to do nono y, which is an educational command. So if you run into a restriction, you do nono y, and it will teach you why something isn't allowed or it is allowed. Let's run that. And as you can see, we have the denial reason. The path is not granted. We only allowed the current working directory. And then it provides you the suggested fix. So that's pretty much how you could get quick started. As you could see, it's literally half a minute maybe. Let's exit out of that. As I said, as you go further and deeper into nono, you might want to author your own pack. I'll showcase profile show GH. This is a profile I authored myself. I use this every single day in my development workflow. For the vast majority of my workflow, I only need access to Claude and GitHub. I do not want it reaching anything else just to minimize the potential attack surface. This is a profile. As you can see, where is it? So we have the network, allow domain, as I said, only Claude and GitHub. And this lists all the groups as well. Groups are smaller compartments with capabilities. These come default. Obviously, deny credentials, some of these are obvious. We do not want it to, by default, have access to your SSH keys, your keychain, so on and so forth. Now let's try running this. Run. And the only difference is I will use my Claude. Actually, I actually have an alias set up, so I don't even have to run all of this. I can just do Claude GH. And within this command, I run nono run, and I use Claude with skip dangerous permissions flag, because I have faith in nono. So as an example, pull a random issue and summarize it in one sentence from nono. It tries to use the GH CLI. It has all the issues. It will pick a random one. As you can see, that worked. We hit the GitHub API. Now let's say hit a random Wikipedia page. It will spend a bunch of tokens just to fail. As you can see, we are protected. We have network filtering. So this probably reduces your attack surface already by 90%. You have file system restriction, network filtering, and then further, you can customize your profile however you want. As I said, I use this every single day in my development workflow. I'll show you how that looks. and all the profiles live in the nono config directory. So let's go into clod.gh. Very simple, as you can see. It's really not a lot of work. We extend the pack that allows us access to everything that Cloud requires, and of course we provide access. We provide packs for most other agent harnesses you can think of: Codex, OpenCode, Hermes. Yeah, you can take a look at the nono registry afterwards. You can have a description, so it shows up nicely formatted when you do a nono profile list. We have network, and these are the domains we allow. Everything is restricted. This is what GitHub needs. Access on my credentials. Yeah, very much more secure than just running basic Cloud without anything, without nono. Cool. So I'll just take a look. I'll return to the slide. So we've gone through this, and of course, you can also validate the profile. So before running your authored profile, you want to make sure that it's actually valid. It's not broken. The schema, the specification is all correct, and this will make sure that it will run. So now going into SPIFFE Spire, as Sal has mentioned, she explained very well. Nono has no idea about anything regarding the authorization aspect. So it doesn't require a static credential. There is no credential within the sandbox whatsoever. In your profile, as I've shown before, you just have a new key, custom credentials. I'll actually showcase that in my terminal. Let's go into SPIFFE mock. So as you can see, we have the same allow domains. We have a custom credential key. We have mock API. This is the name of our custom credential. It then gets further activated when you name it within credentials to be active for this sandbox session. And then we name the upstream you want to hit. For this quick example, I'll just be hitting a mock server just to display the JWT-SVID and it being validated properly. In a later example, I'll be hitting a real production upstream. So we have the SPIFFE block, type, JWT will be performing direct JWT insertion. The workload API socket, so we're pointing where the agent socket lives locally for nono to be able to request an SVID, the audience, and then inject header. Now, for a quick basic background, SPIFFE is the specification of workload attestation, Spire being the implementation itself. And the majority of the burden, it wouldn't make sense to include a lot of the infrastructure within Nono. We are strictly a secure runtime for processes, wrap processes. So you will have to set up a Spire server, have the Spire agent running. Nono itself doesn't care, doesn't know about the selectors, how the workload is attested. It just waits to receive the JWT-SVID itself. So as an example, as I said, I have a mock server running here, waiting for some requests. Let's try to hit that. Let's see. So again, allow current working directory. We choose the profile I just showcased, and then we do a plain curl against our mock API base URL. Very plain. There's nothing else. No headers. Basically as plain as it can get. Let's hit that. As you can see, we get back in milliseconds status OK. It was validated properly. We can see the claims, expiry, the issuer, and then the sub. The sub claim being the SPIFFE ID. So for this example, this is the workload ID. And then if we take a look back at our mock server, it received it, everything is validated, it has not expired, the header, everything has been injected properly. Nono did not see any of this. It was a plain request. Now let's take a look at a more real production environment. First of all, let me introduce the SPIFFE Cloud profile. If you want to hit the Cloud API, they do it a bit differently. It is not direct JWT-SVID insertion. They do OAuth2 client assertion. What this essentially means is nono receives the JWT-SVID after the workload is attested. We hit a token endpoint. Once validation passes, their federation rules properly parse and validate everything, we receive an access token. And then this access token is what is used to hit the real API Anthropic upstream. So it's not too different from the regular direct JWT profile. Once again, we have an upstream, the header, the token URL. This is what the JWT-SVID will hit to receive the access token, and then some extra parameters. These extra parameters differ from upstream to upstream, of course. For Anthropic, this is what they require. Client assertion, as I mentioned, we provide the JWT, we receive an access token, API socket, and the audience. Now let's try to run this. So let's say, hello world. Again, current working directory only, the profile just showcased, and we are hitting Cloud. And just to remind you, in the previous commands, nono ran within milliseconds, so most of the burden here is waiting on Anthropic. Hello, how can I help you with the nono project today? All via OAuth2 client assertion. Now let me go back to the slides before I forget where I'm at. Yeah, we've run the profile, and now let's get to the auditing. So one of the most important aspects of running an agent is, of course, that it can run, it has access to exactly what you need and nothing more, which we've shown. The other aspect is, what if you leave it running? As everyone knows, agents call numerous tools in every single prompt. They love calling tools. And if something does happen, or something has happened, we need to learn, triage, and assess the situation. We have a cryptographic local log that we can take a look at. So let's take a look. No audit list. Let's take the most recent session, which is the SPIFFE call session. Let's get the ID, and then no audit show. So there's a lot of information here, but most important is that we can take a look at the SPIFFE context of that session. We see the workload SPIFFE ID, the trust domain associated with it, the SVID type, in our case it was JWT, and then the source. And then we can also verify. Oops. Let me get the, we can verify that the session was not tampered with. As you can see, the integrity was verified, how many events happened in the session, the chain, the root, the scheme, everything is here to be audited, to take a look, whatever the case might be for your team, your enterprise, and so forth. Let's go back to the slides. Now, I've already showcased some attempts to try and exfiltrate potential information, and I'll showcase some more, and I'll showcase the nono-y command as well. So let's run that profile again, but instead of hitting the Cloud API, let's do something simple. Let's try and cat out the SSH key. High stakes. As you can see, the operation was not permitted. Now if we do nono-y and go towards SSH key, it will tell you that it is denied because it's a sensitive path and the exact details. So it was blocked by this potential policy group and what exactly is blocked. And then going back to static credentials, because you still might have some use case for them. Let's say you have an Anthropic Cloud API key. Sal has mentioned this before, but we have something called phantom tokens. So the nono sandbox, if in the case you are using static credentials, not SPIFFE, the environment, or any other way you are really inserting the potential key, it will never access a real credential. It will always be a phantom token. And then via the proxy layer, via the network filtering, this phantom token is swapped out for the real API key. So we can take a look. Let's do nono run again and do let's do a grep. And let's take a look. Oh, I misspelled it. Apologies. Always making mistakes in demos. I must be doing something wrong. But anyhow, in a real scenario, you can see under documentation, if you do take a look at the environment itself, it will be a variable containing a random string. There's no real token included. As you can see, it will be something like this. And then I showcased this already when we tried to hit Wikipedia. You can also do the exact same thing, no why, and you can take a look why it is being denied. So if we do no, pointing at the host, the port, and our profile is denied because of the proxy filter, domain filtering is active, the suggested flag if you do actually want to allow this domain. And of course, the iterative process allows you to enter then your profile and add this domain if it really is a domain you want access to. Cool. I guess I can pass it over to you, Sal.
Excellent. All right. I thought that was a pretty powerful demo. Again, this is about a week and a half of work of taking nono, which is incredibly powerful, and applying it to one of the security problems that I really liked the framework around for identity, and making sure that we can trust it and audit it. So what I would love today is for us to consider a couple of ways that we can, get involved and understand. So the things that we proved to you in the short demo was that what you're getting here is identity, but not a key. Possession is denied, and you have the ability to scope per call. That combination is so powerful. So if you want to get involved in this today, if you're on this call, you may already know one or more of the maintainers behind this. The real brain behind Nolabs and Nono originally is Luke Hines, and you are familiar with Luke Hines from Sigstore and some of the most serious work I've seen in a decade around attestation of supply chain. This is really what it takes to bring the smartest people around actually getting to the lowest layers of isolation. So if this was interesting to you, we are assigning this to and against any mitigations where we can prove that it is the full mitigation. So keep an eye out on those and let me know if there's any mitigations that I've missed. This is always going to have a free and open source Apache 2 license on Nono. So you have the ability to implement it today, and you should. You should definitely implement it on your personal projects. You should definitely implement it in your production environments. Best ways to get involved right now. You can go and look at our GitHub. We've got a lot of documentation and it's growing quickly. We release regularly. So jump in and get involved. Our Discord is the best place to come and have a conversation with our solutions architects and our maintainers directly. Our documentation does cover the specific SPIFFE implementation. And we are looking for ways and reasons to expand on this work. If you are interested in getting started with Nono today, then I would encourage you to take the little less than 1 minute startup that it takes to get nono installed. And you should go to the GitHub Nolabs nono templates, where I'm going to continue to be adding some good templates for you to consider around work like curl or Git or GitHub or kubectl. And if you are able and willing to contribute there, that is the best place for us to understand what exactly is the profile of isolation you are pursuing and how can we help you to build with that. So, with that said, I've got a look at the questions here, and I would just like to know, we've answered a couple of them, but Alexa, is there anything there that you wanted to dive into and make sure that we answered?
Yeah, of course, there's a bunch of good questions. And yeah, Mihai is totally correct. The demo stress made me forget how to use a terminal. So yeah, I pasted the command into the chat if you scroll above, and you can see the phantom token instead of the real API key. So apologies for that. Now let's address some of the comments. Let's take a look. I saw an interesting one. And yeah, shout out Mihai. He's the person behind the model transparency project on Sixstore. So Scott here can use a separate profile per tool call rather than per agent. So we have something called tool sandboxing, which is a major feature that should have its own webinar. We have many contributions from people at Datadog, Okta, so on and so forth, which they use extensively. And what the idea is, so you've seen me use the Cloud GH profile, where I only allow access to Cloud and GitHub. And you saw my agent Cloud calling the GH CLI. You can further restrict that, for example, by using tool sandboxing, where it can only do GET requests. So if it might go astray, we all know agents love to ask for forgiveness later. And with tool sandboxing, you can further restrict within a micro sandbox the tooling itself. So as I said, GH cannot post to issues, open PORs, if that's your worry. And then this further extends down to not only the GitHub CLI, AWS CLI, anything really, any tooling you could want. And you can look more information about this up in our documentation. It's still a growing subject. As Luke has pointed out, we are starting to collect some of the tool profiles, which you can take a look at. Now let me look at chat again. Can you talk about platform support? I know the WS kernel is missing some capabilities, but I don't know whether that gap is addressable. So we currently have majority support where we can totally stand behind macOS and Linux, of course, because we use the LSM, the Linux security module, Landlock, plus seccomp for Linux, and then seatbelt on macOS. They're very robust. WSL2 has support, but it is not as extensive. However, it should work in a base format. Maybe some of the features won't work, but the base format where you run a pack should be fine. Regarding Windows, if that's also a priority question, there's been some talks in the community, but of course, Windows is a complex beast with its own set of problems, which we'll see if we want to address in the future. There's a very large community outreach. And now let me scroll up a bit further. It should be relatively easy to also get a profile for Codex, right? By Mihai. So yes, up on a registry, you can take a look at the GitHub page, documentation. It will lead you to a registry. We have officially vetted and maintained profiles, packages for a variety of agents. Yes, we do have Codex. Some of our engineering team mainly uses Codex, so it's an extremely high quality pack. There should be no problems. As I said again, open code, Codex, Hermes, Pi, Cloud. We have support for all of them. I see Steven here. Does it use SCITTTS for not having to trust anyone? If you could expand a little bit on that, comment more. I'll reply in a second. Let's see. I see Chris had a very big question, but I appear to have answered it with the audit log. Is there a log of denies that would make sense to then use another agent? Right, so to quickly answer that question, if we run into denials, as you could see when I was presenting, when we tried to do an ls tool call for projects outside of my current working directory, which was the only directory I allowed, it gave us a nono why, giving us the reason. And then nono, after you quit, can further give you a little prompt where it will ask you if you want to grant that denied capability access, and it will be added to your profile. So there is either a human in the loop iterative process where you can yourself tweak around, play with it, see what works best. But also nono does suggest and grant capabilities straight into your profile if you accept. Let's take a look. Are you using anything to restrict the scope or lifetime of your GitHub token that's used within your profile? For that specific profile, I am not. However, that's a pure choice made by me. For example, with the SPIFFE, you saw a clear expiration date on the JWT. And then if it's expired, of course, or close to expiry, it is re-requested instead of being used from the cache. And as I said, if you are using static credentials, you can swap them out, you can restrict the scope, the lifetime, so on and so forth. Srini asks, where are the profiles stored? Locally, on your own host, they're stored in .config /nono/profiles. If we're talking about any packs that you want to pull down, as I said, they're up on the registry. How are the current customers of Nono by Suvasis? So if by customers you mean users, we're about to hit 3.3 thousand stars on GitHub. We only hit 3,000 maybe 2 weeks ago, which is quite crazy when you think about it. It's been blowing up more and more recently, which is fantastic. There's a lot of enterprise use cases. I mean, especially with all the attacks you see lately, even the model attack recently on Hugging Face. There's a lot of need for runtime security regarding agents, and for good reason. You can ask it a simple prompt, can you summarize the project, and it will call 60 tools. You don't know what that's doing. No one's going to be looking through all those tools. So Chris says, this is awesome. Thank you so much, Chris. Can you change profiles in hot reload, or do you need to restart? Yes, you will have to restart. The capabilities are enforced upon instantiation of your wrapped process, wrapped agent, just for security purposes. Hot reloads would be not so good. Suvasis asks, how do you transfer the token to a sandbox? I think the demo has covered it well, but for SPIFFE, there is no token in the sandbox, so that's covered. For static credentials, you outline it inside your profile. So you point it at the keychain, your environment, so on and so forth, even Bitwarden, CLI. And then, as I showcased, the proxy layer injects the real token into the request when it has left the sandbox, aka when it has left the provision of the agent. Cool, let me scroll down. I think I've reached most of the older questions. Let me see.
I think that's most of the questions I definitely wanted us to answer. If there is anything that is burning in your heart that you want a live question answer to right now, make sure to put it into the discussion. If you're still trying to bubble up on exactly what question you are trying to ask or want clarification on, come to our Discord, and we are happy to have that discussion with you. But is there anything else that we want to cover at the moment, or anything that we can give you a quick review on, as we've still got a live demo available?
And as we're waiting for those, I'll just answer some more real quick. Geffen asks, will you send out the recording afterwards? This is recorded. It will likely be split up into clips for LinkedIn, and the full recording is going to be available on YouTube, so you can take a look at that after the stream. Oh, I see Sal's reply. Thank you very much. How are profiles updated in Nono? Any thoughts on how to run this at scale over a team of people and regulate hard limits and things you might allow developers to change? This is an interesting topic. It's something we are actually working on now, an approval backend, if that's what you meant. So you could have a potential administrator. If there are denials, this administrator, let's say the manager of your team, they can take a look at the needs. Say you require access to something that's not allowed yet. He can, in the approval backend, approve and then plus it. And that, furthermore, without the approval backend, again, every project is different, but it's an iterative process. From what I've seen, most teams usually center on one or two agent harnesses. Usually, for example, Claude and Codex. So you would require maybe 2 profiles per project at most, if it's a very specific profile. If it's a basic Cloud GH profile, for example, that works for any project. And of course, the embedded profiles that we have, if you're working on a Go project, Java, Bun, so any of those languages, we do provide embedded profiles that you can extend within your own profile, because if you're running tests, whatever the case might be, those languages might require different permissions. Maybe asking another way by Stephen, how are the records stored? Is it self-attested? So I'm guessing this is to do with the audit log that I showcased. If you are aware of a project called Sigstore, which the founder of Nolabs, Luke Hines, founded, we are following the same paradigm. So we have a Merkle tree. If any node is potentially compromised, it will not verify, and you will be aware of a attack that potentially happened and catch that out. And it is a local log available on the host. The sandbox does not have access, so yeah, sorry for ranting too much. Sal, you can take over now.
That was excellent. No, I wanted to make sure all of those technical questions were maintainer replied. And we've got a link to the Discord in the chat if you want to continue these discussions, which you absolutely should. Again, Nono has more stars on GitHub than Kubernetes or Docker did for the same amount of time. I have never in my entire career seen a project move this quickly, and I think it's because this solves a massive problem that all of you have. So take what you can from this free and open source project, implement it today, and come tell us how to make it better. And thank you all so much for joining in this demo today. I really look forward. I hope to be in touch, and I'll chat with you all soon.
Yeah, thank you so much, everyone, for joining.